And we're back to start section 5.4, right triangle trigonometry. The triangles that we've been working with so far have been triangles that are on the XY coordinate system. So if you have a terminal side here, theta, we were creating right triangles where we have an X coordinate, a Y coordinate, and our radius or arc. But as you guys know, most triangles don't land necessarily on the XY coordinate. We can always put them there, but quite often they're just sort of out in space. We can create a right triangle over here somewhere, where here's the angle that we're looking for, and it's not on or described as being on an XY coordinate plane. So instead of using X, Y, and R, we use words in reference to the angle that we're trying to use. For example, if we're focusing here on angle theta, then we take the R and we call that the hypotenuse. That's the side across from the right angle. And in reference to theta, X is the side adjacent or next to the theta, and Y is the side opposite of theta. So they're all in reference to their position with respect to theta. So if we were to look at the theta on this triangle, then we would have the hypotenuse, which is the side across from the right angle. Then we have the side opposite theta, and we have the side adjacent to theta. So we're going to take our ratios that we know, the Y over R, X over R, and we're going to convert them in terms of opposite, adjacent, or hypotenuse. So keeping those pictures handy, let's look at sine theta, which is Y over R. So Y is the side opposite of theta. R is always our hypotenuse. So sine, we can refer to as opposite over hypotenuse. That's where the SO in SOHCAHTOA comes in. Sine, opposite, hypotenuse. Cosine is X over R. X is the adjacent side. So we can say cosine of theta is adjacent over hypotenuse, which is where the K comes in SOHCAHTOA. And then tangent, being Y over X, is the same thing as saying the opposite side over the adjacent side. So TOA, tangent, is opposite over adjacent. So some people use that phrase SOHCAHTOA to just remember opposite over adjacent or adjacent over hypotenuse, depending on which one that they're using. So sine, opposite hypotenuse, cosine, adjacent hypotenuse, and tangent is opposite adjacent. If you know those three, then you already know all of their reciprocals as well. So let's take a look at the first example where we're asked to find the exact values of all 6 trigonometric functions. Now they're giving us the cotangent of theta is -7 over 24. We know that cotangent of theta is the same thing as cosine of theta over sine theta. So if that was the only information they gave us, we wouldn't know whether it was the cosine that was negative or the sine that was negative. So they have to give us this other piece of information stating that it's the cosine theta that is negative. Now we know that if we have cotangent of theta, which we generally think of as X over Y, we can also consider that as adjacent side over the opposite side. This tells us that the adjacent side is the -7, that's the X or the cosine value, and the opposite side is a +24. So there's one other piece that we need to find, and that is the hypotenuse. I find it helpful to actually draw a right triangle and label the sides that we know. Don't worry about which quadrant it's in right now. We know the signs. So the adjacent side is a -7. The opposite side is a 24. So in order to find our hypotenuse, we're going to use the Pythagorean theorem. -7 squared plus 24 squared equals our hypotenuse squared. The left side is 625 equals h squared. Take the square root of both sides, and we get a hypotenuse of 25. What we're doing here is no different than using the y over r or the x over r. The only difference is we've given the side different names: opposite, adjacent, and hypotenuse instead of x, y, and r. but it's still the same theory. We can do our sine of theta, which we know is opposite over hypotenuse. So that would give us a 24 over 25. Its reciprocal function, cosecant of theta, would then be 25 over 24. Cosine of theta is the adjacent over hypotenuse, which would give us negative 7 over 25. Its reciprocal function, secant of theta, then would be negative 25 over 7. And then tangent of theta is opposite over adjacent, which is 24 over negative 7, which does in fact coincide with its reciprocal function, cotangent, that was already given as negative 7 over 24. Now, there are a couple of terms that are used occasionally when we're dealing with trigonometric reading problems. The first one is angle of elevation. And this is if somebody is looking up. We measure the angle from the horizontal line up to where the observer is watching. It's always in reference to the line of sight to the object. We also have an angle of depression. And this is if somebody is looking down towards an object. It's the measure of that angle from the horizontal line down to what their observer. Again, it's the line of sight to the object. So it's always from the horizontal line up or horizontal line down. So let's do an example. We have a 5'6" hiker standing on top of a 150-foot cliff. So let's draw the cliff. We've got a cliff here. That's 150 feet. And then we have a hiker. He's 5'6". So this gives us a total distance of 155.6 feet. Now, he sights a boat. That's my boat. So he sights a boat at an angle of depression of 24 degrees. So what that means is from his line of sight, from the horizontal down to the boat, is 24 degrees. And they're wanting to know how far is the boat from the base of the cliff. Label that in. Well, we've got a right triangle here. So notice which sides that we're looking at. We have a 24 degree here, but that's outside the right triangle. We can use this triangle if we want, or we know that together those are complementary angles. They add up to 90. So if this angle's 24, this angle here should be 66. You should add to 90 degrees. So we are trying to find n. In that right triangle where we know the angle 66, we are trying to find the opposite side. The only side that we know is the adjacent side. So which trig function uses the opposite and the adjacent? Tangent. So we can do tangent of 66 degrees should equal the opposite side over the 155.6 feet. Now, just a side note, in this problem, they gave us the height of the hiker. So we can use that as, and add it to the 150. If they don't give you the height of the hiker, just go from the bottom of the cliff. 150 feet, give or take 6 feet, it's going to be minimal, okay? So if they give you the height, include it. If they don't, just use the cliff. So now we can solve. If we multiply both sides by 155.6, we get n equals 155.6 times the tangent of 66 degrees. Be sure your calculator is in degrees. And when we put that in, we get approximately 349.483. Remember, they asked for us to round to thousands. Tens, hundreds, thousandths place, so that's 3 decimal places. So the boat is about almost 350 feet away. One of the reasons why we chose tangent instead of cotangent is that your calculator has the tangent button on it. It doesn't have the cotangent. You would have to do 1 divided by tangent to find it. So always use one of your parent functions, sine, cosine, or tangent. In example 11, from a point on the ground 500 feet from the base of a building, an observer finds that the angle of elevation to the top of the building is 24 degrees. So we can draw that. Here's our little person. He's 500 feet from a building, 500 feet away. And it said that the angle of elevation is 24 degrees. And again, they didn't give us the height of the observer, so we're just going to use the ground. Then it says that there's another angle of elevation to the top of a flagpole that's on top of the building. So we'll put a flagpole here. Angle of elevation to the top of the flagpole is 27 degrees. So they're wanting us to do two things. They want us to find the height of the building and the length of the flagpole. Well, let's find the building first. So if we're just looking at the building triangle, we have 24 degrees, we have 500 feet, and we have the side of the building. Again, with that angle, we know the opposite side and the adjacent side. So let's use the trig function that uses the opposite and adjacent. That would be tangent. The tangent of 24 degrees is the opposite over the adjacent. So the n is 500 times the tangent of 24 degrees. So the height of the building is approximately 222.614 feet. And it said round to thousands, so that's 3 decimal places. Now let's focus on the flagpole. Notice that the triangle that just works with the flagpole, you highlighted, this triangle here is not a right triangle. So we can't use the SOHCAHTOA, we can't use those ratios. But what we can do is use this entire triangle and just refer to this as, say, maybe n sub 2, a second height. So that would be the building plus the flag. Well, that triangle has a slightly larger angle of 27 degrees. We're still 500 feet away, and we're looking for that larger height. Again, we've got opposite and adjacent. We're going to use tangent. So we have tangent of 27 degrees equals n sub 2 over 500. Multiply both sides by 500. 500 times the tangent of 27 degrees. And that second height is approximately 254.762 feet. That's the height of the building with the flag, and we have the height of the building. So how do we find the height of just the flagpole? We subtract. So if both of them are 254.762, we take away the building, 222.614 feet, and we get approximately, so 32.148 feet for the flag. That's how high the flag is, and this is how high the building. All right, that's it for us on section 5.4. I hope you're kind of getting the hang now of the new trig vocabulary and the different things that we can do with it. If you have any questions, you know where to find me. Thanks. Bye.